In React, when a user clicks a button, you respond with an event handler. Usually that handler updates state, and React re-renders the UI. Your job is simple. Make the wave button show the greeting, "Hello there." Start the app with Docker. Run Docker Compose up with build and force recreate for the web service. Then open localhost on port 3000. You'll see a wave button. Click it, and nothing happens. That's the bug we're fixing. You only need to edit one file, problem.jsx, inside the web source folder. The rest of the app is just scaffolding. The main file mounts the app. The app component renders the problem component. The style sheet handles appearance. Focus on problem.jsx. At the top of that file, you'll see a state variable called waved, initialized to false using the useState hook. That means waved starts as false. Further down, there's a paragraph that says, "Hello there," but it only shows when waved is true. Right now, it stays hidden. Now find the wave button. It has a click handler attached, the onClick prop, but the handler is empty. It does nothing when you click. We need to update wave to true when the button is clicked. Inside the click handler, call the setter function, set waved, and pass it true. So when someone clicks wave, waved becomes true. React re-renders, and the greeting appears. That's the React pattern. Event, state update, UI update. Save the file. With hot reload, refresh if needed. Click wave again. You should see "Hello there." To confirm, run the test with Docker Compose run test. The test checks two things. On load, the greeting must not be visible. After clicking wave, it must be visible. If both pass, you're done. Quick recap. You wired a click handler to state. The onClick prop listens for the click. Set waved updates the state. And the conditional render shows the greeting. Small change. Core React idea. User actions update state, and the UI follows. Nice work. On to the next one. In almost every real app, the screen changes based on what's going on. A loading spinner while data fetches. An error message when something fails. A welcome message when the user is logged in, and a sign-in prompt when they're not. That's conditional rendering, showing different UI depending on the current state. React doesn't give you a special if component for this. You use ordinary JavaScript, things like if statements, ternaries, and logical operators right inside your JSX. State changes, React re-renders, and the UI updates to match. In this exercise, we'll practice that pattern with a simple login toggle. One boolean, two possible messages. Small example, but the same idea shows up everywhere in React apps. Let's go to the next problem in our React basic problem set on Develow. You can find it in the IDE or online. The idea is simple. The UI should change based on state. Same component, different output depending on what's true right now. Let's open problem.jsx and see what we're working with. Okay, so we've got a component with a piece of state called logged in. It starts as false. There's also a button labeled toggle login. When you click it, it flips logged in. True becomes false. False becomes true. That part's already wired up. What's missing is the paragraph below the button. Right now it always says, "Please sign in," no matter what logged in is. Our job, make that text react to the state. Think about what we want. When logged in is false, user is not logged in, show, "Please sign in." When logged in is true, user is logged in, show, "Welcome back." So one paragraph, two possible messages. The value of logged in decides which one we see. That's conditional rendering. In React, you don't need a special if component. You use normal JavaScript inside JSX. The pattern that fits here is a ternary, a compact if/else. If the condition is true, show this. Otherwise, show that. In JSX, anything in curly braces is JavaScript, so we can put the ternary right inside the paragraph. find the status paragraph, the one with data-test ID equals quote, status quote. Instead of hard coding, please sign in, we'll use logged in to pick the text. Something like, if logged in is true, render welcome back. Otherwise, render please sign in. The comment above the paragraph basically tells us the same thing. We're just making the JSX follow that logic. Save the file and look at the preview. On load, logged in is false, so you should see, please sign in. Click toggle login. Logged in becomes true. The text should switch to welcome back. Click again, back to please sign in. If the text updates every time you toggle, you've got it. When state changes, React re-renders the component. On each render, the ternary runs again with the current value of logged in. That's the core idea. State drives what gets rendered. You're not manually updating the DOM. You describe what the UI should look like for each state, and React handles the rest. That's conditional rendering in React. One line of logic inside JSX, tied to a Boolean in state. You'll use this everywhere. Loading spinners, error messages, empty states, showing different content for logged in versus logged out users. When you're ready, run the tests. They'll toggle login and check that the status text matches what we expect. Nice work. You've got it. In React, there are two common ways to manage form inputs: controlled components and uncontrolled components. With a controlled component, React state is the source of truth. That means the input value is stored in state, and every time the user types, an onChange handler updates that state. This gives you full control over the input. It's useful when you need real-time validation, conditional rendering, dynamic UI updates, or when the input value affects other parts of the page. With an uncontrolled component, the DOM manages the input value internally. Instead of updating React state on every keystroke, you use a ref to access the value only when you need it, usually when the form is submitted. This can be simpler for basic forms, quick inputs, or cases where you don't need to react to every change. The key idea is this: controlled components give you more control. Uncontrolled components give you less React state and simpler code. Both approaches are valid. In interviews, the important part is knowing when to use each one. Use controlled components when the UI needs to respond immediately to user input. Use uncontrolled components when you only need the final value. Let's go to the next problem in our React basic problem set on Develow. You can find it in the IDE or online. This one is called a controlled input. If you've been building React apps for a while, you probably already do this every time you make a form. But if it's new to you, this is the pattern that ties an input field to component state. Open up web/src/problem.jsx. That's the only file you need to edit for this problem. Look at the starter code. At the top, you see an import from React, useState. Below that, the problem component creates state with const text, set text, equals useState with empty quotes. So far, so good. State is set up. Now look at the JSX. There's a text input with an area label of your text. Under it, a paragraph that says you typed, and then a span that displays the text variable. Try it in the preview. Click Run App or open localhost 3000 in your browser. Type in the field. Nothing happens in the echo, right? The input takes your keystrokes, but the span below still shows nothing. Why? Because the input is uncontrolled. The browser owns what appears in the field. The text state in React is separate. It only changes when you call setText. Nobody is calling setText when you type, and nobody is telling the input to show the text state. In React, form inputs are usually controlled. That means two things work together. 1. The displayed value comes from state. 2. Typing updates that state. Think of it like a loop. State drives what the input shows. The user types. An onChange handler updates state. React re-renders. The input shows the new state. round and round. The comment in the starter code tells you exactly what to add. Make the input controlled by adding value equals text, and on change to update text. Let's walk through it step by step. First, bind the value. On the input tag, add value equals text in curly braces. Now the field always displays whatever is in the text state. Right now that's an empty string, so the field looks empty. Good. Second, wire up the change handler. Add on change equals, and then an arrow function. Inside, call setText with the new value from the event. The pattern is setText, open parent, e.target.value, close parent, ye.target.value. When the user types, React passes an event object to your handler. E is that event. E.target is the input element. E.target.value is whatever text is currently in the field. So the full input looks like this. Input with aria label your text. Value equals text in curly braces. On change equals an arrow function that calls setText with a dot. Target.value. Save the file. The preview should hot reload. Now type in the field. As you type, the "you typed" echo updates live. Every keystroke goes into state. State re-renders the span, and because value is bound to text, the input stays in sync. Try typing hello. The field shows hello. The echo shows hello. Delete a letter. Both update together. That's controlled. Let's talk about what happens under the hood. You type the letter H. The browser fires a change event. Your onChange handler runs. setText is called with H. React schedules a re-render. On the next render, text is H, so the input value is H and the span shows H. You type E. Same loop. Text becomes HE, then HEL, then HELL, then hello. The UI always reflects the state. This pattern is everywhere in React. Text area, controlled. Checkbox, controlled. Select dropdown, controlled. If you need to validate input, disable a submit button or pre-fill a form from an API, controlled components make it straightforward. React state is the single source of truth. What if you only add value but forget on change? The field would show the state, but typing wouldn't update it. React would warn you in the console about reading a controlled input without an onChange handler. The field feels frozen. Always pair value with onChange. What if you only add onChange but forget value? Typing updates state, and the echo works, but the input itself is still uncontrolled from the browser side. For this problem, you need both. When you're happy, run the tests. In the terminal, run Docker Compose, run --rm tests, or use the Run Test button in Develow. The playwright test opens the app, finds the input by its label, your text, types hello into it, and checks that the echo span with data test ID echo shows hello. If your input is properly controlled, the test passes. Let's recap. useState holds the text. Value equals text ties the input to that state. On change calls, set text with e.target.value, so typing updates state. The you typed span already reads text, so once the loop is wired, everything just works. That's a controlled input. Small change, big pattern. Once you see it here, you'll spot it in every form you build from now on. One of the most common use cases for useEffect is running code when a component first mounts. You'll often see this pattern with an empty dependency array. When React sees an empty dependency array, it runs the effect after the component renders for the first time, and then it won't run again unless the component is unmounted and mounted again. This is incredibly useful for initialization logic. For example, fetching data from an API, loading user information, connecting to a service, or setting up event listeners. Let's walk through what's happening here. First, the component mounts. React renders the UI. Then, after the render completes, the useEffect callback executes. In this example, we're making an API request to fetch a list of users. When the data comes back, we update state using setUsers. That state update triggers another render, and now the UI displays the loaded data. A common interview question is, why not just fetch the data directly inside the component body? The answer is that React components should remain pure during rendering. Side effects like API calls belong inside useEffect. The key takeaway is simple. If you want to run something once when the component loads, use useEffect with an empty dependency array. It's one of the most common patterns you'll encounter in React applications and technical interviews. This is a small React app built with Vite. When you open it in the browser, you'll see a single message in the center of the page. At first, it says loading with an ellipsis. Your job is to flip that to ready with an exclamation mark, but only after the component has mounted. Let's look at how the app is wired together. The entry point is main.jsx. It finds the root element in the HTML page and renders the app component into it. App is just a thin shell. It wraps everything in a main tag and renders one child, the problem component. All the work for this exercise lives in problem.jsx. That's the only file you need to edit. Open problem.jsx and you'll see the starter code. At the top, React's useState hook is imported. Inside the component, we create a piece of state called ready, along with its setter, setReady. Ready starts as false. The return statement is a simple conditional. If ready is true, we show a paragraph that says ready with an exclamation mark. If ready is false, we show a paragraph that says loading with an ellipsis. So on the very first render, ready is false, and the user sees loading. That's correct so far. But nothing ever changes ready to true. The screen stays stuck on loading forever. That's the bug you need to fix. Here's the key idea. Setting state during the initial render would work, but it wouldn't teach you anything useful. In real apps, you often need to run setup code after React has painted the component to the screen. Things like starting a timer, subscribing to an event, or fetching data from a server. You don't do that work during render. You do it in an effect. React gives you the useEffect hook for exactly this. The signature looks like this. useEffect, open parenthesis, a function, close parenthesis, comma, and then a dependency array. When you pass an empty array as the second argument, you're telling React, run this effect once, right after the first render, and never run it again. That pattern is called running on mount. So here's the solution, step by step. First, update your import. Change the first line from importing only useState to importing both useEffect and useState from React. Second, add the effect inside the problem function after your state declaration and before the return statement. Write useEffect, open parenthesis, arrow function, open curly brace, setReady, open parenthesis, true, close parenthesis, semicolon, close curly brace, comma, empty square brackets, close parenthesis. Let's read that back in plain English. After the component mounts and React finishes the first render, React calls your effect function. Inside that function, you call setReady with true. That schedules a re-render. On the second render, ready is true, so the JSX switches from the loading paragraph to the ready paragraph. That's the entire fix. Two small changes, import useEffect and add one effect with an empty dependency array. Why the empty array matters. If you left off the second argument entirely, React would run the effect after every single render. That's usually not what you want for one-time setup. If you put values inside the array, React would rerun the effect whenever those values change. An empty array means no dependencies, so the effect runs exactly once on mount. You can verify this in the browser. Start the app with Docker Compose, then open localhost port 3000. You should briefly see loading, then ready. In practice, the switch can happen so fast you might only catch ready. That's fine. The important part is that ready appears after mount, not that loading lingers on screen. The project also includes an automated test. Playwright opens the page and checks that the text "ready" with an exclamation mark is visible. Before your fix, that test fails because loading never goes away. After you add the use effect, the test passes. To recap, use state holds whether the app is ready. The component renders loading while ready is false. Use effect with an empty dependency array runs once after mount and calls set ready true. React re-renders and the user sees ready. That's use effect on mount. Import the hook. Run your setup code inside the effect, pass an empty array, and React handles the rest. This video is only the beginning. The best way to learn product engineering isn't by watching videos, it's by building, by exploring code bases, by implementing features, by debugging real problems, and by developing the skills that modern companies actually evaluate. That's exactly why Develow exists. On the platform, you'll find curated problem sets covering front-end development, back-end development, databases, APIs, system design, and full-stack engineering. You can search problems by topic, technology, or skill level, and practice inside a development environment designed specifically for modern interviews. Whether you're preparing for your first role, looking to level up your fundamentals, or getting ready for FANG-style interview loops, the goal remains the same. Build strong fundamentals. Learn how applications work. Use AI to accelerate your growth and focus on solving real problems. Everything we've covered in this roadmap can be practiced directly inside Develow. You can get started for free, explore the problem library, and download the platform today on both Mac and Windows. Thanks for watching, and I'll see you in the next lesson.